7.5, determinants and Kramer's rule. The very first section, they want us to find the determinant of 2 by 2s. Just keep in mind when you want to find the determinant, it has to be a square matrix. So the very first section is 2 by 2s. And if you will recall, if you have a very nice ABCD 2 by 2 matrix, you can do a little shortcut, which is AD minus BC. So that's what I'm going to do for all three of these. All right, we just have to be careful with signage because that minus in the middle gets people. All right, for number 3, we'll have -1 times 3 minus -2 times 5. So we'll have -3 minus -10. So be very careful with signage. And we will have a +7 for that number 3 determinant. Number 5, same thing. It's a 2 by 2. We'll have 9 times -1 minus 3 times -3. And that will tell us -9 minus -9. And that gives us a determinant of 0. Yes, you can have a determinant of 0. Everything will be just fine. And then last but not least, for this section for 7, 3 times -2 minus 4 times 5 is -6 minus 20. So we get -26 as our determinant. Now for number 9, they're just starting you off with some baby steps of finding the determinant of a 3 by 3 because there are quite a few steps. So they want us to find the cofactor of row 2, of each element in row 2. Now, the main thing you're going to do, if you want to find the determinant and you need to find your cofactor, you have to remember your sign matrix. So your sign matrix looks like this. It's opposites, positives, and negatives, always starting with a positive. So since we're going to do each element of row 2, we're going to have negative for the 1, we're going to have a positive for the 2, and we're going to have a negative for the 0. Not that the 0 matters. Now, the element only helps for the cofactor in telling us what is going to be crossed out, essentially. So if I look at my first one, it's in row 2, column 1. So I'm going to cross out row 2, column 1. Okay, I'm going to cross out row 2, column 1. I'm going to erase this in a minute, but I just wanted to show you in yellow. So what will be left over is 0, 1, 2, 1. So I'm going to undo that and write down 0, 1, 2, 1. Okay, now keeping in mind the cofactor for all these wonderful math words is the sign and the determinant, the sign and the determinant of the minor matrix. So we'll have, I'm going to do the minor matrix first, just we'll worry about the sign later. So we'll have 0 times 1 minus 1 times 2. 0 minus 2 is -2, but then I have the negative down here. So the cofactor, is +2. That's what they are looking for in this section. Just find that cofactor. All right, now we're going to do the same thing for 2. If you look at your sign matrix, 2 is in the middle of my matrix. Positive is the sign in the middle of my sign matrix. That's why I have +2. Now, if I were to cross out row 2, column 2, I'm crossing it out. Now I'm going to erase it. I'll have -2, 1, 4, 1. Okay, so -2, 1, 4, 1. All right, and for the cofactor, I need my sign, and I need the determinant of this matrix. Okay, and just like I did before, I'm going to do the determinant first. So I'll have -2 times 1 minus 1 times 4. Negative 2 minus 4 is negative 6, and the good news is I have a positive here, so my cofactor for 2 in row 2, column 2 is negative 6. Last but not least, we've got the 0. Now, if we were multiplying our cofactor by our element, we would be very happy because it'd be 0 times the cofactor, which would be 0. However, that's not what they're asking for. They're asking for the cofactor. So if I were to cross off where 0 is, row 2, column 3, I'm going to undo that. I'd have negative 2, 0, 4, 2. So negative 2, 0, 4, 2. Again, they're just asking for the cofactor, which is our sign, and then the determinant of our minor. So the determinant is going to be negative 2 times 2 minus 0 times 4. So we'll have negative 4 minus 0, negative 4. However, we've got a negative down here. So we've got negative 4, which means our cofactor for the 0 in the second row would be positive 4. Again, they're not asking us for the total, what happens when we multiply the element of the whole thing. When we multiply the element 0 times 4 to get 0, they're just asking for the cofactor. That's why it is not 0. All right, number 13, they want us to find the determinant, as you can see, DET. Now, the problem with finding the determinant of a 3 by 3 is you can pick any row, you can pick any column. I don't care which one you pick. The second thing you have to remember is your sign matrix. You need all your signs, otherwise everything gets screwed up. All right, so me personally, since, I'm lazy like you guys do, I want to have the least math possible. And what you have to remember with your determinant, you're going to find your cofactor, which is your sign and the determinant of your minor, but then you're going to multiply it by the number, the element from your determinant. So I'm going to choose row 3. The reason I'm going to choose row 3 is because of this beautiful 0 right here. Because eventually I'm going to have to multiply by 0, and that will give me 0, so I don't have to do a lot of that math. I erased my 3. Okay, so in order to do that, I need my signs, my element, and then the minor. So for negative 6, I need a positive from my sign matrix. I need the negative 6, and then I need the minor. So just like the last problems, I'm going to cross out row 3, column 1, because that is where negative 6 is. I'm going to erase it, but we want to see that our minor is negative 7, 8, 1, 3. So I'm going to say negative 7, 8, 1, 3. And what I'm going to do is I'm going to set this up first. I'll do the math in just a few minutes. So when I choose row 3, my next number will be 3. Now, if I look in my sign matrix, I'll have my negative, then I'll have my element of 3, and 3 is in row 3, column 2. So when I cross out each row and column, I have left over 4, 8, 2, 3. 4, 8, 2, 3. 2, 3. 2, 3. Okay. And then last but not least, I'm going to write it down. So I'll have a positive 0, but then do I really care what's here? No, because this is going to be 0. Now, just for practice, if I were to cross out row 3, column 3, I would have 4, negative 7, 2, 1. But again, don't care because we're multiplying by 0. So this is going to end up being 0. Done. All right, so let's come back and do a little math here. starting from the left side. So to find the determinant of our 2 by 2, we're going to have negative 7 times 3 minus 8 times 1. Negative 21 minus 8 is negative 29. Then I'm going to bring the positive and the negative, so I'll have positive negative 6 times negative 29. I do not know what that is right off the top of my head. I'm going to say I don't know, 29 times 6, 174. So close. All right, and it'll be positive, so we're going to go 174 for that element of our 3 by 3. And then we're going to go do the math for our negative 3. So let's do our determinant. 4 times 3 minus 8 times 2. So I'll have 12 minus 16 is negative 4. But then, zoop, negative, zoop, 3. So I have negative 3 times negative 4, which is positive 12. And then, of course, the 0. And what I'm going to do is I'm going to add all of these together. So 174 plus 12 is a total of 186. So that is the determinant for this matrix. Remember, determinant is a number that represents a matrix. Each matrix has its own single number, so we're sticking with 186 for this determinant. All right, number 17, again, they want us to find a determinant of a 3 by 3. Don't forget your sign matrix, very important. Okay, now we get to pick any row or any column we want. Unfortunately, I don't have any zeros anywhere, so I'm going to stick with the old-fashioned row 1. Most people will pick row 1 when they don't know, so I'm going to do the same thing. Now, if I pick row 1, let's see, for my 10, I will have a positive 10. And if I cross out my row 1, column 1, 4, 3, 8, 10 is what I have left over. So 4, 3, 8, 10 is what I have left over there. Sticking with row 1, I'm going to have the 2 here. And I will have a negative sign in front of that from my sign matrix. If I cross out row 1, column 2, negative 1, 3, negative 3, 10. Negative 1, 3, 1, 3, negative 3, 10. And last but not least, I'll have a 1. The sign is a positive from my sign matrix. And if I cross out row 1, column 3, I'll have negative 1, 4, negative 3, 8. Negative 1, 4, negative 3, 8. Okay, so now I get to do math. The first thing we want to do is find the determinant of the 2 by 2s, which is the shortcut little formula. So we're going to do 4 times 10 minus 3 times 8. Shoop. So that'll give me 40 minus 24, which is 16. Then I will have a positive and a 10 that I have to multiply by 16. So I have positive 160. All right, not done unfortunately. We still have to do 2 more computations. So the determinant 2 by 2, negative 1 times 10, minus 3 times negative 3. Watch your signs. We're going to have negative 10 minus negative 9. That comes out to be a negative 1. But then, zoop, I have a negative and I have a 2. So negative times 2 times negative 1 is positive 2. Last but not least, negative 1 times 8 minus 4 times negative 3. Watch signs. Negative 8 minus negative 12. Negative 8 plus 12. Well, I'll just keep writing it. It's positive 4. Bring the sign and the element down. 1. Positive 1 times 4 is positive 4. And we get to add all these suckers together. And we end up with 166 is our determinant for this 3 by 3. If you're doing your math with a different row or column and you can't figure out what you're doing wrong, if you're getting it wrong, please ask me before class, after class, whenever. I can certainly try to help. Okay, 21. This is our last practice problem for 3 by 3s. So hopefully you're getting it. We've got 3, 3, negative 1, 2, 6, 0, negative 6, negative 6, 2, and I didn't write it, I didn't write it down, but they want us to find the determinant of this 3 by 3 matrix. It's a square matrix, so we are allowed to do that. I love a 0 because we'll have to do math multiplying by 0, so I'm going to choose row 2. Now again, you could pick any row you want. If you are a row 1 person and you're going to do row 1 every single time, do row 1. It does not matter. The determinant should come out to be the same number. All right, so I've got my sign matrix going on here. And I'm going to pick row 2. So row 2 starts off with a 2. My sign with row 2 is a negative. Then I'm going to cross out row 2, column 1, because that is where my 2 is. And I will have 3, negative 1, negative 6, 2. 3, negative 1, negative 6, 2 as my minor matrix. Then I'm going to move on over to our 6. And if I look at our sign matrix, we'll have a positive 6. If I cross out row 2, column 2, I will have left over, let me undo all that. Sorry. I will have left over 3, negative 1, negative 6, 2. Is that right? Shoink, shoink. Yes, okay. And then, last but not least, for my 0, I would have 0, and just for grins, I'm going to put in my minus sign. And just for grins, I'm going to put in my leftover matrix, 3, 3, negative 6, negative 6. Just for grins. Do we have to? Absolutely not, because we would be multiplying by 0, because this is going to be a 0 anyway. So we don't have to really worry about that. All right, now we're going to find the determinant of the 2 by 2s of the minor matrices that we have written down. So for the first one, we'll have 3 times 2 minus negative 1 times negative 6. 6 minus 6 is 0. Oh, we love 0. So it doesn't even matter if I multiply that by a negative 2. We get 0. Okay, and then here we'll have 3 times 2. We have the same thing. Minus negative 1 times negative 6. So 6 minus 6, another 0. I can't write it correctly, but hopefully you can add all these numbers together. I have faith that you can, to get 0. So now, when we add all these wonderful things together, do you want to guess what we get? Oh, 0. Look at you. So smart. 0. Yes, you can have a determinant of 0. 0 is okay. And that's what we got for our determinant for 21. All right, for this section, they're going to ask us to solve for x. So they are going to do a little bit of wonderful algebra along with our determinant skills. So for 27, it says the determinant of this 2 by 2 matrix, it's a square matrix, so we can find the determinant, and it equals 0. So now they've set up an equation, and they want us to solve for x. All right, so first we're going to find our determinant. Since it's a 2 by 2, we can do our AD minus BC shortcut. So we're going to have negative 0.5 times x minus 2 times x equals 0. All right, well, I'm hoping you can solve this. Negative 0.5x minus 2x equals 0. So negative 2.5x equals 0. And if you divide anything, if you divide 0 by anything, you should still get 0. Okay, that was way too easy. We're going to have to do another one. All right, so now let's do 29. 29 says 2x, 11x equals 6. So this one will be a little bit more challenging. A little bit. Okay, now it is determinant of this. I did not write that down. Okay, 2x, 11x equals 6. So, again, it's a 2 by 2. We're going to do our little shortcut. So I'll have 2x times x minus x times 11 equals 6. 2x times x, 2x squared, minus 11x equals 6. Oh no, algebra, from college algebra. What will we do? Well, we are going to set this sucker equal to 0 because it is a quadratic equation. So let's move that 6 over. We'll have 2x squared minus 11x minus 6 equals 0. And you have two options. You can factor or you can do the quadratic formula. So whichever makes you happy, do that. I'm going to factor. Now I know since there is a number, let me get a color here. Since there's a number in front of this x squared, it's not as easy as many of you like. But if you are good at factoring, heck, have at it. I'm going to factor. I can't pull out a greatest common factor, so I'm going to have 2x and 2x. Then I'm going to have minus 6 and positive 1 equals 0. How did I do that? I've been doing this for 40 years, so, you know, I started doing this in 7th grade. So that's how I know how to do that. If you are not good at factoring, if you want to know how to factor like that, because it will be very helpful in calculus, please come see me. 15 minutes is pretty much all it'll take for me to explain how to just throw down numbers and you know that they're right. I'm going to finish this off, but I'm also going to do the quadratic formula because I know some of you will do the quadratic formula. Now we take each factor, set it equal to 0, and solve. So we get 6, and we get negative 1/2. So for this problem, we have two answers. Now you know what you could do. Check your work. But that's okay. All right, so what I'm going to do is I'm going to come over here, and I'm going to do the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4 times a times c. There's a lot of negatives in here, so be careful. All over 2 times a. So that will give us 11 plus or minus the square root of 121 plus, because it's negative times negative, and 8 times 6 is 48 all over 4. I'm going to try to squish this in here. So 11 plus or minus the square root of 169 over 4 is 11 plus or minus 13 over 4. Now I'm going to squeeze it right here. 11 plus 13 is 24 over 4, which is 6. We already, so I'm checking my work basically. And then I have 11 minus 13 over 4, which is negative 2 over 4, which is a negative 1/2. So however you choose to do this, you can factor it, you can do the quadratic formula, but you will get a negative 1/2 and a positive 6. And I don't care how you do it, whatever makes your heart happy. And that is 29. All right, 31, I think this is the last determinant just for finding determinants. So this is our last puzzle problem, I would call it. All right, now this time we have a 3 by 3. So for the determinant of a 3 by 3, now you have to remember you need your sign matrix, you need your minor matrix, you need all kinds of stuff. But you do get to pick your row or column. Now, as I've explained, I like having a 0 somewhere in my choices because eventually I'm going to multiply that element of 0 times something, which will just be 0. In this case, row 1 has a 0 in it. So I'm going to choose row 1. Now don't forget, sign matrix. Okay, so first I'm going to use the 4 element, and with that 4 element I will have a positive, and I know you don't have to write the positive, I just always write the sign from the sign matrix for habit. And 4 is in row 1, column 1, so I'm going to have 0, 1, x, negative 1. 0, 1, x, negative 1 as my minor matrix. All right, then I'm going to move over to 3, and with 3 in my sign matrix I will have a negative, and if I cross out row 1, column 2, I will have 2, 1, negative 3, negative 1. 2, 1, negative 3, negative 1. And I'm going to throw the 0 in there, just like I haven't done in the past, just for practice. So I'll have a plus 0. And then my minor matrix would be 2, 0, negative 3x. Do we care? Not really. And this was all equal to 5. Right? Yeah, 5. Okay, so now we're going to find the determinant of each 2 by 2. The third one, no, we don't care about because it's 0. So we're just going to throw 0 in there. All right, for my first minor matrix, 0 times negative 1 minus 1 times x gives me 0 minus, and you can put 1x if you want to, which is just negative x. Bring down the plus 4. Multiply that by negative x, and we get negative 4x. Okay, for the blue, we're going to have 2 times negative 1 minus 1 times negative 3, negative 2 minus negative 3. Watch your signs. And we end up with a piddly little 1. So we'll have negative times 3 times 1. That gives us negative 3. We have the plus 0, don't really need it. So now what I'm going to do is I'm going to bring this equation over here. I'm going to have negative 4x minus 3 equals 5. I'm hoping you can solve this. Negative 4x plus 8, or equals 8. Man, I can't even solve it. We're having a bad day. So x is negative 2. And so we've done the little puzzle problem. We did what they asked. They wanted us to solve for x. We got negative 2. I say we're good because I think my math is correct. Next, we're going to move on to Kramer's rule. All right, 57, this is where we're starting Kramer's rule. Now, as I explained in class, Kramer's rule is just a very long, drawn-out way of solving a system. Instead of, for example, doing elimination right now and getting rid of the y's if we were dealing with the letters. So we're going to take the next 15 minutes and solve this when we could have solved it in 3. But that's okay. All right, so Kramer's rule, what you get to remember is you have all kinds of D matrices. So you have a determinant matrix, you have a D sub x for your x variable, a D sub y, and sometimes you have D sub z. So you get to remember D is your coefficient determinant. So we're going to have 1, 1, 2, negative 1. D sub x is when you take your D matrix and substitute your x values with your constants. So we'll have 4, 2, 1, negative 1. And then D sub y, we take our determinant matrix, replace our y values with our constants. Oh, I didn't put my little thing here. Okay, so now what we're going to do is we are going to find the determinant of each of these little matrices that we just created. The good news is these are 2 by 2, so shouldn't take too long of an idea. All right, so we're going to have 1 times negative 1 minus 1 times 2. So -1 minus 2 is -3. Now I'm not going to do anything with this. I'm just finding these values for the moment. All right, d sub x. So we'll have 4 times -1 minus 1 times 2. -4 minus 2 is -6. And then last but not least, I should probably label these being a good instructor and such. So we'll have 1 times 2 minus 4 times 2. 2 minus 8 is -6. Oh, very boring. All right, so how do we compute our variables using Kramer's rule? We will take our d sub whatever variable, and we will divide by our d. So that means we'll have -6 over -3, -6 over -3. So x is 2 and y is 2. So could we have done that, 5 minutes ago? Absolutely. Let's see. So 2 plus 2 is 4 if I put it in the first one, and then 4 minus 2 is 2 if I put it in the second one. So I actually have checked this. Done. Kramer's rule. Okay, 59. Again, we're just doing Kramer's rule. So we're going to set up our d sub x, and our d sub y. D are the coefficients in front of your variables, so we'll have 4, 3, 2, 3. And then d sub x, we're going to replace our x values with our constants. 3, 3. And then our d sub y, we're going to replace our y constants, our y coefficients with our constants. The one thing you have to be careful of when you're doing d sub x and d sub y is you always start from your coefficient matrix. A lot of people, since they're doing the y, they'll put it in the x matrix, and then you have the same exact numbers every time. So just be careful of that. All right, now we're going to find our determinant of each one of these. So 4 times 3 minus 3 times 2. 12 minus 6 is 6. -7 times 3 minus 3 times -11. -21 minus -33. Watch your signs. So we end up with what? 12, I think? 12. And then we'll have 4 times -11 minus -7 times 2. -44 minus, careful, -14, doink, doink, is -30. Okay, so keeping in mind, remember how to solve for each variable. X is d sub x divided by d, so that'll be 12 over 6 is 2. And then y is d sub y over d, which is -30 over 6, so we get -5. Now you can check your work. 4 times 2 is 8. 3 times -5 is -15. 8 minus 15 is -7. So far, so good. If we put it in the second equation, 2 times 2 is 4. 3 times -5 is -15. 4 minus 15 is -11. So we have our answers. Doink. All right, another Kramer's rule, which is a 2 by 2. Well, your matrix will be a 2 by 2. All right, so here we go. We'll have D, which is 3, 2, 6, 4. D sub x is replacing our x coefficients with our constants, so 4, 8, 2, 4. And then D sub y, we replace our y coefficients with our constants. Okay, here we go. So for D, we're going to have 4 times 3 minus 2 times 6, which is 0. Okay, we're done. We can't tell what x and y are. We just know they don't have a nice normal xy solution, because remember, to find x, you do d sub x divided by d, which is 0. We can't do that. That's very bad. And if we did this, we'd have 16. We have this. That's not good. So now you get to go back and do it old school way and figure out, do you have infinite solutions or do you have no solution? So I'm going to come back over here. And again, since D is 0, we can never divide by 0. So all it's telling us is we don't have a regular solution meaning an actual point. We have to go find, do we have infinite or no solution using our old methods. So using our old methods, I'm going to multiply the top by -2. I'll have negative 6x minus 4y equals -8. So what that tells us, I have 0 equals 0. So that means we have infinite solutions. I'm happy if you know we have infinite solutions. If anybody asks, get it in terms of x or y, you can take one of these equations and isolate one of the variables. It does not matter which one. And so x will equal 4/3 minus 2/3 y. So you can say, okay, y is our dependent variable, and then x is 4/3 minus 2/3 y. I don't need that. I'm very happy if you find out it is infinite solutions. I'm good with that. So if you came over here and you're like, oh, it's infinite solutions, and you told me it's infinite solutions, I'm good to go. Okay, now I'm giving you 2 homework problems for Kramer's rule for 3x3s. Just for practice, just so you know how to set them up, know how to solve them, and get on with life, because there's so many different ways we can solve this. That's what this chapter is about. Find a system and find a way to solve it. So specifically, we're going to do Kramer's rule here. If you can find one variable, you can probably find all the other variables, but I will take the time and do every single one of these. So fun. Okay, it's going to take a lot of room, so I'm going to write a little bit smaller than usual. Now my D matrix would be just my coefficients: 4, -1, 3, 3, 1, 1, 2, -1, 4. My D sub X matrix, remember you take your X coefficients and replace them with, oh, this is going to be so nice. You replace your X values with your constants, but you keep the rest. And then D sub Y, I don't even know where to put this. I'm going to put this really close because our D sub X is going to be pretty nice. So D sub Y, our D sub Y is actually, all of our lettered ones are going to be really nice. So D sub Y, we keep our X values from original, our X coefficients. We replace our Y coefficients. So -3, 0, 0, and then 3, 1, 4. And then D sub Z, which I can squish in here too because that's going to be nice. I keep my X's, I keep my Y's, but my Z's are now replaced with my constants. Okie dokie, here we go. So now we have to use our wonderful skills of our minors and our cofactors and all that kind of fun stuff. So I'm just going to put a little reminder over here: plus, minus, plus, minus, plus, minus, plus, minus, plus. And then I'm going to compute the determinant for D in as little space as possible. I'm going to choose row 2. The only reason I'm choosing row 2 is because it doesn't have any negatives in there, and messing up all the signs would be just a pain. All right, so with 3, I'll have a negative and my 3, and then my minor matrix would be -1, 3, -1, 4. So if I crossed out row 1, column 1, that's what would be left over. Now if I do my 1 in the middle, I'll have a positive with my 1 element, and then I would have 4, 3, 2, 4. 4, 3, 2, 4. Because I would cross out row 2, column 2. And last but not least, I would have 1 with a negative sign in front, with 4, negative 1, 2, negative 1. Because with 1 here, cross this out, 4, negative 1, 2, negative 1. All right, let's go do a little math here, all cramped up. So I'm going to have negative 3, and then I'm going to have negative 1 times 4 minus 3 times negative 1. Oh, I'm going to run out of room. So negative 3 times negative 4 plus 3 is negative 3 times negative 1, which is positive 3. So no room. Okay, then. Oh, dear. Okay. Darn it. All right, that was a positive 1. So I'm going to have 4 times 4 minus 3 times 2. So I'm going to have 16 minus 6 is 10. Positive 1 times 10 is 10. So I left out a lot of math there. I apologize. I'm out of room. All right, and then last but not least, I'm going to have this negative 1 up here. So I'll have 4 times negative 1 minus negative 1 times 2. So I'll have negative 4 plus 2, which is negative 2. I have a negative 1 up there, so I have a positive 2. All right, which gives me 10, which gives me, I add all these together, doink, 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 and I get 15. I hope I did that math right. Okay. So as you can see, we have other ways of doing this. It would be just lovely if we could do those things. All right. Now, the reason I said earlier that these are a lot easier to compute, and I should have moved them down, I apologize for running out of space over here, is for D sub x, I'm going to choose column 1. The reason I'm going to choose column 1 is because of these fabulous zeros. And that way I only have to do one computation. So I have my element, which is negative 3. I have my sign from my sign matrix as a positive. And then my minor would be 1, 1, negative 1, 4. And then I'm going to stop. The reason I'm going to stop is because I would have a minus 0 times something, and I would have a plus 0 times something, which is just 0. So I don't need that. All right, so let's do the math here. I'm going to erase that 0, 0 stuff. Get out of here, 0, 0 stuff. Bye-bye. And then undo. Oh, making me undo. Ah, sugar. The yellows. Okay, my fault. I apologize. So we decided on 1, 1, negative 1, 4. Okay, which means I have 1 times 4 minus 1 times negative 1. So I have 4 minus negative 1, which is 5, plus negative 3. So I get negative 15 for my D sub x. That's just my D sub x, unfortunately. Oh my gosh. Okay, now D sub y, I'm going to choose column 2 for the same exact reason. I'm going to choose column 2. Good golly. Now, I have the negative 3, but it's in the middle, so I'm going to have minus negative 3. And then my leftover matrix would be 3, 1, 2, 4. And I have zeros everywhere else, so I just don't care. So 3 times 4 minus 1 times 2. 12 minus 2 is 10. And I have a negative negative 3, so positive 3 times 10 is 30. So 30 is my D sub y. And then last but not least, I'm going to choose column 3. So so I'll have a positive with our -3, and then my leftover 3, 1, 2, -1. Oh boy. 3 times -1 minus 1 times 2. -3 minus 2 is -5. Multiply that by -3. I get positive 15. Unfortunately, we are so not done yet. Okay, I'm going to squish this in over here somewhere. Okay, so x is d sub x, which is -15 d sub x all over d, which was 15. So x is -1. Okay, y is d sub y over d. D sub y is 30 over 15, so y is 2. And finally, z, d sub z over d. D sub z was 15, d was 15, so z is 1. Good heavens to Betsy. Whew. So what do we have? -1, 2, 1. You can check that if you like. I wish you luck. All right, last one is 67. Now, I know, they're a pain. I keep giving them to you, but it's good for you. Last one, 67. This is on the final exam. That's why I'm giving you 2 of them. Basically, you have to know the setup. On the final exam, it's just a setup. It's not the computation usually. And if it is the computation, then it's usually just find one of the variables, not all 3. So yes, we're taking time to find all 3, but on your test or on the final, it's basically find one of the letters. Like go find Y or something, something like that. Okay, so here we go, setup. I'm going to try and write smaller than the last problem. So D is our coefficient matrix. 3, 2, -1, 1, 4, 2. And then again, let me make sure very quickly that I wrote this correct. Okay, I did. All right. And instead of writing down all of these right now, I'm going to do the math for these, just so I can figure out my spacing. All right, here we go. I'm just going to choose row 1. And remember signs. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, if I choose row 1, I'm going to have a positive with my 2. And then my leftover matrix will be 2, -1, 4, 2. Where'd that come from? I cross out row 1, column 1. Okay, then I'm going to have a negative sign based on my sign matrix with a -1 because I'm going across row 1. And I will have leftover 3, -1, 1, 2. Where does that come from? I'm going to cross out row 1, column 2, where that 1 is, that -1 is, sorry. Doink, doink. Okay. Is it a -1? Yeah, -1. Okay, good. Last but not least, I will have a positive sign from my sign matrix and a 4, and I'm going to squish in 3, 2, 1, 4. So if I crossed out row 1, column 3, where the 4 is, that's where that minor matrix comes from. Okay, so let's do a little math. Now, the reason I'm doing this, and I should have done it in the first one, if you find out that D is 0, then you know you have to go do this another way. I'm not saying this is 0. I have no idea what this is going to come out to be. But I should have done that in the last problem before I started finding everything else. Okay, so here we go. We're going to do a little math here. We're going to do 2 times 2 minus -1 times 4. So we have 4 minus -4 is 8. So we have positive 2 times 8 is 16. Then we will have 3 times 2 minus negative 1 times 1. So 6 minus negative 1 is 7. And we have minus minus 1, so we have positive 1, which gives me 7. Last but not least, squishing it over here, 3 times 4 minus 2 times 1. 12 minus 2 is 10, but then I have this plus 4. That's going to give me 40. So I have 16 plus 7 plus 40, and they're all positive. Really? Okay, so what does that give me? That's 23 and 40, so that gives me a total of 63 for D. Okay, now we're going to go try and find D sub x. I'm going to do this just one at a time for space purposes, and just so you're understanding, if I said go find one number, that's what you have to do. So in this case, if I just said go find x, you find your D, and then you go figure out your x using D sub x. Now D sub x, remember, you take your original determinant and you replace your x values with your constants. So my constants are negative 2, negative 3, 17, and then you keep the rest. So negative 1, 2, 4, and 4, negative 1, 2. Okay. All right, let's see how much room I've got with this one when I do the math, because there's no zeros, unfortunately. All right, I'm going to be lazy and pick row 1. So if I pick row 1, I'll have a positive with a negative 2, and my matrix will be 2, negative 1, 4, 2. Because if I cross out row 1, column 1, that's what's left over. Okay, then I'll have a minus because of my sign matrix, and then I have a minus 1. What's left over there? That'll be negative 3, negative 1, 17, 2. I think I'm going to need my calculator. That came from crossing out where the negative 1 was, the row and the column. Okay, one more. Positive from my sign matrix with a 4. And I will have left over negative 3, 2, 17, 4. Okay. So we'll have 2 times 2 minus negative 1 times 4. 4 minus negative 4 is 8. So this time negative 2 times 8, we get negative 16. And then we'll have negative 3 times 2 minus negative 1 times 17. Negative 6 minus negative 17 is 11. And then we have negative 1 times 11. 11. My fault. Sorry. 11. So that's 11 because this will be a positive 1. And then negative 3 times 4 minus 2 times 17, negative 12 minus 34 is negative 46. We're going to multiply that by positive 4, so we get negative 184 maybe? Let me check, 46 times 4, 184, negative 184. All right, then we're going to add all these together, so negative 16 plus 11 minus 184 is negative 189. Okay, so if we wanted to find x, we have d sub x divided by d. d sub x we just figured out is negative 189. We're going to divide that by 63, and negative 189 divided by 63 is negative 3. So after all that work, we find out that x is negative 3. Lucky us. Okay, now you can see why on your test or on the final exam they would either ask you just to set up the problem or they would ask you to solve just for one single variable, because this just took us eons. I have no idea how long it took us. Just for space purposes and for time purposes, and so, I'm over it just as much as you are. y should come out to be 4, and z should come out to be 2. So there you have it. D sub y, let's do a little backwards math here, should come out to be 252, and D sub z, if you're doing the math, should come out to be 126 once all is said and done, if you do it correctly. I know, I got lazy there. If you would like me to check your work, if you're not coming out with those answers, please see me before or after class, and I can definitely help you. Last problem, and just the space and the moving and all the time. So, like I said before, I started writing the X and Y stuff. You should definitely know how to set up D sub X, D sub Y, D sub Z. And you should know how to do the setup to solve for X. Meaning, I know X is D sub X over D. I know Y is D sub Y over D. And I know Z is D sub Z over Z. So you should know the setup just for time purposes. And then on the test or the final exam, we'll ask you either for the setup or just to solve for one variable. So that's why I just solved for X here. You are more than welcome to try to solve for Y and Z. Know the setup, know how to find at least one of them. You should be good to go for Cramer's rule.